Hello and welcome to INE's CCI Service Provider version 5 Learning Path. Today in this course we will look at ISIS route leaking. So if you know in ISIS we have two levels of routing, right? We have level 1 routing, we have level 2 routing. Level 1 is usually intra-area and level 2 is inter-area routing. However, route leaking becomes an important aspect when you have routers running multi-level, where you have some routers running level 1, some routers running level 2, because as you know that the metric is 10, which is default in ISIS for every hop, there could be a suboptimal routing. So so when you have something like this, when you have multi-level configuration, you should do route leaking to avoid suboptimal routing. So route leaking can be done from level 1 to level 2, or we can do route leaking from level 2 to level 1. So, and if you want to learn more about route leaking, it's basically defined in the RFC, which is RFC 2966. Let me show you an example of why and when you would use route leaking. Look at this example. I have some routers which are configured as L1. So router 1 and router 2 are basically configured as a pure level 1 router. So these two routers are pure level 1. So these two are level 1 routers. I have two level 1, level 2 routers, which basically takes router 1 and 2 outside of the area. So think of these two routers like the ABR. So these are level 1, level 2, and R4 is also level 1, level 2 routers. Similarly, in area 5, 6, 7, 8, I have some routers here. All of these routers are level 1, level 2 routers, and R8 is a level 1 router. Now let's say if R2 needs to get to R8. How is the traffic going to go? He is going to go to router 4, router 7, and then router 8. Why is he going to choose that? So, as you know that level 1 routers, they only maintain level 1 database, which means they only know about other routes or other routers in the same area. They only know about that. They do not know anything outside the area. So if they have to go outside the area, they have to choose the L1, L2 router to go out of the area. Now, from R2's perspective, there are two L1, L2 routers to go out of the area. One is router 4 here, or there is router 3. So R2 has two paths, right? He could go from here, or he could go down to R4. Now let's assume that this link had a cost of 30, and this link had a cost of 60. Or maybe we increase this cost to 60, and this link had a cost of 10, this had 10, this had 10, this had 10, this had 10. Now what's going to happen? For R2 to go through this path, the total cost is 10 plus 10 plus 10, that's 30, 40, 50, and this is 10, total is 60. If he goes down to R4, his total cost is 10 plus 60 plus 10, total cost becomes 80. Which path is he going to take? Would he take towards R1 or would he go towards R4 directly? The answer, you may think that it actually goes to R1 because the cost is lower, right? But that's not going to happen. Whenever an L1 router needs to go out of the area, he looks at the L1, L2 router, the closest L1, L2 router. Now from R2's perspective, which is the closest L1, L2 router? R4 is the closest because the cost is 10. And the second L1, L2 router, which is R3, has basically a cost of 20. So to reach R3, the L1, L2 router, the cost is 20 versus R4, the cost is 10. So R2 would basically do a suboptimal routing even though the total metric through R4 is 80 versus through R1, which was 10, 20, 30, 40, 50, 60, which was 60. So he will still choose R4. Because in ISIS, the total metric is always 10 per hop. So if I have to go from one area to another area, I will always look at the metric to the closest L1, L2 router. Now this can cause suboptimal routing. To avoid this, R4 or R3 may leak the routes. He may leak L2 routes into L1. So he would leak L2 into L1. So basically R2 now gets a longest prefix match from R3. He would choose that rather than choosing a default route from R4. As you know that we have R1 and R2 configured as L1, they would never see specific routes. They would only see a default route, which would be towards the ABR, which is towards the L1, L2 router. Basically, R3 and R4 would by default set the attach bit, which tells R1 and R2 to create a default route towards the L1, L2 router. So R2 creates a default route towards 4, and R1 creates a default route towards 3. So R1 goes correctly as per the best path because for him the closest L1, L2 router is R3, but for R2 the closest L1, L2 router is R4. So for R2 there's a suboptimal routing happening which you do not want. So if I leak the route, then R2 would choose the longest prefix because prefix length is always first, then is the AD, then is the prefix length, then is your metric in fact. So it's always prefix length, AD, and then metric. Obviously before metric, like OSPF, how we have OIA, again here we have L1 is preferred over L2. So sometimes you may want to do route leaking to avoid suboptimal routing. So let's try this out. What I'm going to do is I will take some routers. We'll look at this topology here where we would actually configure some route leaking. We will leak some routes from L1 into L2. We will leak some routes from L2 into L1. We can also filter the routes through the route leaking where I don't want to leak certain routes to a neighbor. I could do that also. So if you look at this example, I have route leaking configured on a Cisco IOS router using a route map. So obviously on iOS XZ, we would do route maps, and on iOS XR, we would use routing policy language, which is RPL. So here I'm actually leaking some routes from level 1 into level 2. So here I'm calling for the route map L1 to L2 leak, which is here. And I'm saying that deny sequence number 10, prefix access list, which is my level 1 to level 2. This is my prefix list, which basically says if it's 2.2.2.2, do not leak this route. If it is any other route, leak that route. So I can even define that which route should I leak and which route should I not leak. Or I could just be like creating an access list or a prefix list which says match this network 5555, call that in a route map which is L2 to L1 leak and say permit, which basically means that only that specific prefix should be leaked. So these are two separate examples. In one example, I was leaking just one route from level 2 to level 1, which was 5555. And in the second example, I was leaking from level 1 to level 2 all the routes except 2.2.2.2. So let's in fact try this out. What we would do is we will take 6 routers, 6 iOS XZ routers, and we would take 2 XR routers. XR routers uses route policy for achieving the same thing. We would basically configure route policy language, so basically an RPL. So if you look at this example, I have a route policy configured called ISIS route leaking, which says if the network or if the destination includes 3.3.3.3 or 4444, then pass, then end the if, and then end the policy. And here I've said propagate, so the command in iOS XZ was redistribute, and in iOS XR it is propagate. They still mean the same thing, that I am going to leak the route from level 2 into level 1 or level 1 into level 2. So here we are leaking level 1 into level 2. Or in fact level 2 into level 1 using this example. So here I have this topology, 6 routers, they all have been pre-configured as multi-level, and let me in fact show you what's been pre-configured. So all of these routers, R1, R2, R3, R4, they are basically in one area. The area is 1, 2, 3, 4. The domain is 49. 5 and 6 are basically in a second area, which is area 56. And XR1 and XR2 are in a different area again, area 1920. R1 has been pre-configured as a pure L1 router. R2 has been pre-configured as a pure L1 router. R3 is an L1, L2 router. R4 is an L1, L2 router. R3 is running L2 adjacency with R6. R4 is running L2 adjacency with R5. And here I have L1 adjacency. R6 has been pre-configured as a pure L2. R5 is a pure L2. XR1 is also pre-configured with ISIS as L1, L2, and XR2 is a pure L1. So what's going to happen here? R3 and R4, which are the L1, L2 routers like an ABR, they would set the attached bit and send that information to R2, and R2 would create a default route towards the closest L1, L2 router. Now for R2, both the routes are equal cost, so he would see both in the routing table as equal cost best path selection. So what I'm going to do now is let's try some route leaking. Maybe what we can do is we can make traffic from router 1 destined to R5's loopback go through router 3. So we would probably have R1, when he does a trace route, it should go to R2, from 2 to 3, from 3 to maybe 5 or 6, and 6 to 5. Assumingly we want that. Or basically we want that the exit door for R2 to get to 5555, which is the loopback of R5, it should go from R3. It should not use R4. Okay? At the same time, we would also achieve something like maybe R2 wants to go to R6's loopback and he wants to exit out from R4. So to get to 5555, which is here, 5.5.5.5.5, it should go from here to here, and from R3 it should exit out. So probably it's going to go to, it could go down here also, because my neighborship here is an L2 neighborship between 3 and 4, so it could go down. I don't really care, but it should go from R3. It should not use R4. And to get to 6666, which is here, it should go down here to R4 and exit out. So it could go directly from 4 to 6, or it could go from 4 to 3. Typically, it's going to go from 4 to 6 directly because they are L2 neighbors also. And the cost is going to be lower for R4 to get to R6 from the direct link versus it going from 4 to 3 to 6. So it should go from 4 to 6 directly. Let's try this out. So the first thing what I'm going to do is look at R2 first. Let's look at his show ISI's database. Here, as you can see, both the L1, L2 routers, R3 and R4, they both are setting the attach bit, which you can see here. The attach bit is set because they are the L1, L2 routers. So that tells R2 to create a default route towards the closest L1, L2 router. Now for R2, they both are equal cost. The metric is 10. So if I do a show IP route ISIs, I see a load balancing happening for the default route because the metric is basically the same. So if I do a trace route right now, trace route to, let's say, 5.5.5.5, it went to 3, it went to 4, it went to 5, it went to 4. So basically it did a load balancing. It sent one packet to 3, one packet to 5. From 5, it went to 4 directly. But what if I want that it should always go to 3 for destination 5555, which means only R3 should leak that route, not R4. If R3 leaks the route of from level 2 into level 1, he cannot leak a route which is from level 2 to level 2 because R2 is running only level 1 adjacency with R3 and R4. So our R2 cannot accept level 2 updates. He cannot accept those. So the only way for R2 to choose R3 is if R3 leaks level 2 into level 1 as a specific prefix. So for achieving that, I would go back to R3 and create a prefix list that says, let's say R5 loopback 0. Let's name this loopback 0. Okay, that's my prefix list. Permit 5.5.5.5/32. Let's now create a route map which is going to be named as, let's say, level 2 to level 1. That's my route map name. Permit sequence number 10 and match IP address the prefix list name. I don't need to give another permit statement because whatever is denied would not get leaked. So whatever is denied in the route map does not get leaked. Whatever is permitted gets leaked. So I have said that a route map L2 to L1 permit 10, which matches my prefix list. So that specific route is the only route which is going to be leaked because route map has an implicit deny, which means all the remaining routes would not be leaked. Now I would attach this route map to my redistribute statement by saying router ISIS redistribute ISIS IP level 2 into level 1 using the route map name that I have here, and enter. Look at the effect of this on R2. If I do a show IP route ISIS, he basically has all the routes are leaked as of right now. Let's go and check. So I see right now that I have intra-area routes, which is L1, and I have some ISIS inter-area, which is right now leaked through R3. We have to see why all the routes are basically getting leaked. So for this, what we would do is go back to R3 and verify our config. So I have show IP prefix list, show run section include IP prefix list, R5 loopback 0, that matches that specific route. Show run section route map. The route map says permit 10 to get leaked. And show run section router ISIS. I have redistribute ISIS IP level 2 into level 1. So I should only see that one specific route being leaked. Let me go back to 2 and check his routing table. In fact, right now, besides this route, I'm also seeing all the specific routes, which shouldn't be the case because we are actually defining the route map and route map has an implicit deny. So let's go back to R3 and remove that temporarily. Redistribute ISIS IP level 2. Because the routes are coming as level 2 on R3, if I check his routing table, show IP route ISIS I believe the routes are coming as level 2 from R5. It is as level 2. So redistribute level 2 into level 1. And then I should be calling for the route map level 2 dash level 1. I don't know if this is to do with the naming convention, but we can try renaming the route map. Let's see again, show IP route ISIs. Yeah, it's kind of leaking everything, which shouldn't be the case. Let's go and rename the route map and do a show runs section route map. And let's say no route map L2 L1, and let's name this route map L2 to L1. Permit sequence number 10. Match IP address prefix R5 loopback 0. And then go back to router ISIS, redistribute ISIS IP level 2 into level 1 and route map the route map name. So it does work now. So it's kind of finicky with the route map name. So probably didn't like the way I had given the name for the route map. And it's surprising that it does not give you an error. It just accepts the route map name, but just doesn't work. So it is working now. Our R3 is basically leaking that one specific route. So how do you think R2 is going to go to 5555? Would he use the default route to the L1, L2 router, or would he use 5555? Obviously, he would use the longest prefix length, which is /32. So he would now go to R3 for destination 5.5.5.5. He goes to R3, to R6, to R5. And that is what we wanted. Now we wanted the same thing for the reverse way, that if R2 does a ping or a trace route to R6's loopback, it should route through R4. So I could achieve the same thing, that it goes through R4 for going to R6. In fact, let's do a bit differently this time, because it's the same config, right? If I just go to R4 and create a prefix list and a route map and attach that to a redistribute statement, R4 would leak the route. But let's do this differently. Let's say if I say that for destination 5555, R2 should choose R3, which is happening right now because I leaked that route. But what if I say that for all other destinations, it should prefer R4? So maybe on R4, I could leak all the routes, all the specific routes, except 5555. So in that case, for destination 5555, he would choose R3, not R4. He would not choose the default route through R4. Instead, he would choose R3 because of longest match. For all other prefixes, he would go to R4 because R4 is sending him specific prefixes, but R3 is sending him a default route. So let's try this out. So now I'm going to do it the other way around. On R4, I would create a prefix list which says R5 loopback 0, permit 5.5.5.5/32. So I'm matching R5's loopback again. Now I'll create a route map, and let's name this L2 underscore 2 underscore L1, and say deny sequence number 10, match IP address prefix R5 loopback 0. So if this loopback 0 matches, so if it's 5555, don't send that to level 1. else, I would send everything else. The else here is done with a route map, again, with a permit statement, but just give a higher value than sequence number 10. So let's say 1000. And then go back to router ISIS, say redistribute ISIS, IP level 2 into level 1, and route map is going to be level 2 to level 1. What's the effect going to be on R2 now? You would see that if I do a show IP route ISIS, I have all the routes. So for 5555, I'm preferring R3, not R4, because R4 is not giving him 5555. And for other routes, I am preferring R4, which you can see here as my next hop. So you see, I could do a route leaking from L2 into L1. Let's also try maybe leaking a route from L1 into L2. So maybe we'll try filtering this time. So leaking L1 into L2 is pretty much the same thing. I create a prefix list. I call the prefix list in a route map with a deny statement, and then everything else is permitted. And then I give the command redistribute ISIS IP level 1 into level 2 and route map. So leaking is pretty much the same thing. So let's try this time denying a level 1 route going out of the area. So for example, let's say if I wanted that R1's loopback should never go out of the area. It should never be advertised outside the area. As of right now, everyone is getting that route. So if I look at R5, show IP route ISIS, he has the routes to 1111. He has the routes as L2. Because R3 and R4, who are the L1, L2 routers, they automatically change level 1 routes into level 2 and advertise it outside the area. Something like OSPF. If you remember in OSPF, there was LSA 3. So as soon as the ABR receives LSA 1, he blocks LSA 1 going out of the area and he sends LSA 3 to area 0. Same thing happens here, is that the L1, L2 router would basically not send L1 update to the L2 area. In fact, he would send L2 update to R5 and R6. So I can maybe filter that route, that don't advertise this route outside the area. So I could do that by going back to 3 and maybe creating another prefix list that matches R1 loopback 0, say permit 1111/32, then create a route map which says level 1 to level 2 and deny sequence number 10, which matches IP address prefix R1 loopback 0, and everything else can go out as L2, so permit 1000. This time I would apply this to router ISIS and say redistribute ISIS IP level 1 into level 2. Route map would be the route map name. The effect of this would be that other areas, outside areas, would not be able to see the route coming from R3. I obviously have to configure this on R4 also. So let's copy that, show IP prefix. Let's copy this on R4 also. And let's copy the route map as well. So I have route map, level 1 to level 2, and then router ISIS. Let's copy that statement also. So now both R3 and R4 should not be sending that loopback 1 of R1 out of the area. So if I look back at R5 or R6, show IP route ISIS, they should not have the loopback of R1. As you can see, the loopback of R1 is missing now, which means I basically filter the route for the routes are only now contained within the area, within area 1, 2, 3, 4 only R1, R2, R3, R4 would have the routes for R1's loopback, but it would not be sent outside the area. So route leaking can be done from level 1 into level 2, which basically causes filtering. If I don't do route leaking from level 1 to level 2, all routes are going to be sent outside the area as level 2. But as far as level 2 into level 1, that does not happen automatically because the routers inside, they are level 1 routers only, so they don't see specific routes by default. They only see the attached bit and they create a default route towards the L1, L2 router, which basically may cause suboptimal routing. So you may want to leak level 2 into level 1 so that suboptimal routing does not happen. So similarly, we can achieve the same thing, or we could do the same thing on XR1. For example, let's say if I wanted that XR1 should leak specific routes to XR2, I could do exactly the same thing. So basically, I'm going to leak level 2 into level 1. As of right now, XR2 is configured as L1 only, which means he would not have specific routes. He would only have routes of area 1920 and a default route because XR1 sets the attached bit, which tells XR2 to go to the closest L1, L2 router. XR2 does not have specific routes at this point of time. So if I look at XR2, show route ISIs, he only has intra-area routes or just a default route. So if I do want to leak something, I could leak something on XR1 because XR1 is the L1, L2 router. So I could probably go to my XR1 and leak a route from level 2 into level 1. So for here, there's no route map. We have to create an RPL, which is a route policy language. Basically, a route policy is what we will have to do. And route policy uses RPL, which is the route policy language. So let's create a route policy. Let's name this ISIS leaking with L2 to L1. So here my condition is going to be if destination includes, let's say we leak the loopback of R3 and R5. So I would say 3.3.3.3, comma, /32 first, comma, 5.5.5.5/32. So if these are the two routes, so think of this like me creating like a prefix list, matching these two routes, calling that in a route map as far as IOSXZ is concerned. So it's pretty similar to that. I could use a prefix set also to match these two routes. So maybe I could use a prefix set and call these two routes and then say if destination is the prefix set name. So I'm not creating a prefix set at this point of time. I'm just directly calling that in my route policy by saying if destination includes 3.3 or 5.5, then what should I do? Then I would say pass. So I want to leak this route, right? So basically it's like a route map with a permit statement. Pass this. Then I would say end the if and end policy. Now I go back to router ISIS 1 and address family IPv4. And here the command is different. It's not redistribute anymore. It would be propagate command. So propagate level 2 into level 1 using the route policy name, which was ISIS leaking level 2 into level 1. Let's do a commit. The effect of this would be if I look at XR2 show route, he should get those two routes which are basically leaked, which you can see here. I see IA and IA for these two routes. Those two routes were basically leaked. Leaking level 1 into level 2 is exactly the same thing. So if I was, let's say, blocking XR2's loopback to not be advertised outside the area, I would do it exactly the same way how I did it on iOS XZ. I would basically create a route policy which says if destination includes XR2's loopback, which is 20.20.20.20, then I would not say pass, I would just say maybe drop, and else I would say pass. And then end if, end policy. Apply that to the propagate command which says level 1 into level 2. So basically what's going to happen in that case is that XR2's route is not going to be advertised outside the area. All remaining routes would be advertised outside the area. I hope this video was informative to you, and thank you for viewing.